All right, so this free response question is primarily based on topics from Unit 1 in the AP exam. And basically what it says, let f be the function defined by the following, where a and b are constants. Anytime we have general a and b's, it sort of throws us off. So it says the graph of f has a horizontal asymptote at y equals 3. And f has removable discontinuity at x equals 2. We want to show that a is equal to 6 and b is equal to negative 13 in part A. So in order to accomplish part A successfully, and just so you know, part A was worth 4 points. So in order to realize how to do part A, we need to first investigate where did this key piece of information, f has a horizontal asymptote at y equals 3, come from. So that key piece of information comes from the idea that the limit as x approaches infinity of this function has to equal 3, because that's properties of horizontal asymptotes. We know that as x is getting really, really big, that it's approaching the asymptote. And in this case, since the power of the top and the power of the bottom are the same, then the coefficients of a over 2 must also equal 3. So we can work backwards to solve for a, and we get that a is equal to 2 times 3, which is 6. Now, once we know a, we can use that to solve for b. So since this has removable discontinuity at x equals 2, what that means is that the numerator and the denominator both share a factor of x minus 2. So we're going to take ax squared plus bx plus 2, and we're going to put that over to x squared minus 8, and we're going to factor the denominator first. So what we're going to do is take out a 2, and that leaves me with x squared minus 4, and we know that x squared minus 4 is a difference of squares. So you get x minus 2, x plus 2. And again, we know that if we have a removable discontinuity at x equals 2, that x minus 2 had to be one of the factors that is going to cancel. So we have it in our denominator. We know that a is 6 up in my numerator. So we kind of have two choices here. We either know that the denominator has to equal 0 when x is 2, or we can try to work backwards and say, okay, 6x squared plus bx plus 2 has to have a factor of x minus 2. So if that's the case, then we know this has to be 6x. We know that 2 times negative 1 would give me my positive 2 there at the end. 6x times x would give me 6x squared. So I could kind of FOIL in the middle to go backwards to figure out what b would be. So x times 6x is 6x squared, negative 1x, negative 12x, positive 2. And again, if I combine like terms, that negative 13x would have to equal my middle bx, which means that my b has to equal negative 13. So again, that is how you verify that a is 6 and b is negative 13. So we've successfully earned 4 points on part A. Now for part B, it says to make f continuous at x equals 2. So what that means is we need to get rid of the removable discontinuity. f of 2 should be defined as what value? So basically what we're trying to say is for continuity, we know we need three things. The definition of continuity says, 1, that f of a is in my domain. 2, that the limit as x approaches a from the right equals the limit as x approaches a from the left. And part 3 is that the limit as x approaches a of f of x is equal to f of a. So that means we need the limit of this function. So we need the limit as x approaches 2 of f of x to equal f of 2. So we know now that a is 6 and b is negative 13. So we look at the limit as x approaches 2 of 6x squared minus 13x plus 2 all over 2x squared minus 8. And what's nice is I previously factored this up above. So that means the limit as x approaches 2 of 6x minus 1 times quantity x minus 2 all over 2 times quantity x plus 2, x minus 2. And then we know that x minus 2 is our removable discontinuity, so it cancels. So then we see that we have the limit as x approaches 2 of 6x minus 1 all over 2x plus 2. So then we, at this point, can plug in our 2. So we get 6 times 2 minus 1 over 2 times 2 plus 2. So you get 12 minus 1, which is 11. 2 plus 2 is 4. 4 times 2 is 8. So it says, at what value should we make f of 2 be defined? Well, in order for the limit to equal the function, f of 2 must equal the limit value, which is 11/8. All right, for part C, it says, at what value of x does f have a discontinuity due to a vertical asymptote? Give a reason for your answer. So again, this is really just, do you know your vocabulary? A vertical asymptote occurs when the denominator is equal to 0, but, and here's the big but, only after you have canceled like factors with the numerator. AKA, you found the wholes. So our like factors were at x equals 2. The vertical asymptotes will be at when the rest of the denominator is equal to 0. So again, that's the 2x minus 2, x plus 2. But we know that the x minus 2 was where the whole occurred. 2 can't equal 0. So the vertical asymptotes will occur when x equals negative 2. Again, this was only worth 1 point. This is really just testing, do you know when vertical asymptotes occur and why do we care? Well, we care because as we move further into calc, if something has a vertical asymptote, then it's discontinuous. If it's discontinuous, then it is not differentiable.